Imagine you are working with data that has complex, nested relationships, like an organizational chart with employees and their managers, or deeply nested comments on a forum. Finding all the descendants of a specific manager, or quickly tracing the entire lineage of a comment, can be surprisingly challenging with traditional database approaches. This is where a clever technique steps in to simplify those intricate queries. The closure table pattern effectively handles nested data by explicitly recording every path between ancestors and descendants in a separate table. Instead of just storing a direct parent-child link, this pattern precalculates and stores all possible ancestral relationships, making operations like finding all children or all parents of a node incredibly efficient and straightforward. This pattern shines by offloading the complex, recursive querying often required for hierarchical data into a dedicated structure. While other methods like the adjacency list pattern are intuitive for direct parent-child relationships, they typically requiring multiple self-joins or recursive common table expressions for deep queries, which can be computationally expensive. The closure table avoids this by maintaining a comprehensive map of all transitive relationships, storing both direct and indirect connections between nodes. This redundancy, though seemingly counterintuitive, is the key to its query performance. To implement a closure table, you will typically create an auxiliary table that contains at least 2 columns, an ancestor identifier and a descendant identifier. For every node in your main data table, there will be entries in the closure table linking it to itself, its direct parent, its grandparent, and so on, all the way up to the root. When a new node is added, you insert a record linking it to itself, and then for every existing ancestor of its parent, you also create a record linking that ancestor to the new node. Deleting or moving nodes involves more complex updates to this auxiliary table, but the benefit lies in the speed of retrieval. One significant advantage, often overlooked, is the pattern's adaptability to various depth requirements. Unlike the nested set model, which can become unwieldy with frequent structural changes, the closure table scales well with dynamic hierarchies because relationships are stored as distinct rows, not as calculated ranges. This makes operations like finding the shortest path between 2 nodes, or checking if one node is an ancestor of another, simple single-table queries, which is a powerful asset in systems requiring rapid navigation through complex structures. Ultimately, the closure table pattern transforms the challenge of hierarchical data navigation from a recursive computational task into a simple lookup operation. By explicitly detailing all relationships in a dedicated table, it provides a robust and performant solution for querying nested data, offering clarity and speed where traditional methods might falter, and enabling developers to build more responsive and scalable applications.
If this helps you code smarter, like, subscribe, and stay tuned for more.